Hello friends, today we are going to talk and continue on welding aspect. We just finished on the WPS sheet 1 and sheet 2 and the importance of giving details in the WPS columns and rows. It's not only filling up some numbers but really describing the entire welding the way we want really to happen from joint to joint and from job to job. If required, we'll rewrite new WPS or we'll keep on writing WPS to suit specific jobs or specific tools. Today we are going to talk on the PQR as you see here, and as we have learned earlier, the PQR is a procedure qualification record. That means whatever we have planned in WPS, is it going to meet the specifications, the requirements of customer, and is it going to meet our internal target as far as achieving the non-destructive test or the NDT results, the distortion levels, the surface finish, machining allowances, or the tolerances as welded and post weld heat treatment, are we meeting them or no? There is two ways of looking at the PQR. One is, the first and most important part of the PQR is to demonstrate by choice of various essential, non-essential and supplementary essential variables, and by stating them in WPS, we intend to achieve all the physical properties and the prescribed non-destructive test results on a coupon plate, which is easy for testing. For example, if we are going to have a shell of 30 millimeters and a distance of 40 millimeters, we will choose either 30 or 40 millimeter thickness and cut two plates of roughly 150 millimeter width and about 300 to 500 millimeter length, depending upon the number of tests we want to conduct on it. And the test facilities what we have. Suppose our UTM is on the 20 ton, then probably for 40 thick plate we may have to do separate out the upper part and the lower part, the first 20 millimeters and the next 20 millimeters, and then test them out. So in that case, the number of specimens or the length of the plate required is going to be more. So we'll have to calculate the number of specimens we intend to do it. In case we want to keep any specimens for retest in case we find some results abnormal, or while testing, cutting, there is some kind of a rework by which there is going to be a rejection of the standard specimen size, then we may have to keep that provision. However, even though we will be making it to a 500-600 millimeter length, it may or may not simulate the actual conditions on the job. For example, a shell can be of 2 meter, 3 meter diameter, and the weight of that 20 millimeter or 40 millimeter plate could be more than a ton, whereas the two coupon plates what we will be welding will be in few kgs, say around 100 kgs. So 1/10 of the size of the shell we will be having a coupon. So this consideration is important for us to remember while we are going to be qualifying PQR. So like the WPS has a unique number, PQR also has a unique number. We give one or two WPS references as we propose to qualify on a test coupon, the PQR. So one PQR may qualify 2 or 3 or even more WPS, and similarly one WPS may have 2-3 PQRs for supporting and qualifying it. The revision number, welding processes which we will be deploying, type of processes, manual, automatic, robotic, or any other specifications of that particular joint. If you want to write it, we can prescribe it there. the joint details, the way we have prepared the PQR, and all the references for preparing PQR will be taken from WPS, where we are going to give the joint design, root gap, root face, included angle, and if we can record the mismatch, which is very likely to happen during the actual fabrication due to certain limitations of our processes, infrastructure, fixturing, and the rigidity of certain alloys and shapes. So we'll have to find the tolerance under which this mismatch is allowed, and we can record it while PQR. Or there are codes like AWS D1.1 where they are asking deliberately whatever is your proposed mismatch, proposed maximum root gap, minimum root gap, included angles as it is going to happen on the job, and make accordingly number of PQRs or mockups and qualify it in a test coupon. Actual variety, making a shell and cutting it will be very expensive, and that's where we are going to limit it to the PQR plate. The next is, once again, these are all the details as explained in WPS, whether we have used backup, if backup is used, what kind of a backup, what is the material of the backup, how the backup has been cleaned, treated, or if there are some requirements on the backup, how we have achieved. And for the backing for the root run, if we are going to give, certain times we give argon purging, or we give ceramic backing, or we try to create some kind of a vacuum to evacuate the fumes and the pressure which is getting built up at the back of the weld, which may impact on the depth of the penetration, so we evacuate it. So like that, runs are given. And for the subsequent runs in stainless steel, many times we deploy after root run or after root plus one more pass, the hot pass, we may start spraying water from the bottom of the weld while we are welding from the top, so that the excess heat is extracted and the sensitization of the weld coupons may be avoided. It will improve in having a better corrosion properties, and sometimes we get a good impact properties also, because there is no sensitization, so the impact properties don't deteriorate, and we get a good impact in stainless steel up to -196 degrees Celsius. Similar to this, there are sometimes we use argon or combination of argon, helium, or other mixed gases, not only for root run but for the subsequent runs also, as we don't want a slightest discoloration happen, especially in aluminium or in titanium mainly. So those are the things which are required to be specified in this area. Then as given in WPS, we will be writing down the material specification for PQR, what we have used. We have a possibility to use a different grade of material as long as it falls in the same P number. But as far as possible, try to use similar or the same material, and don't take advantage within the code. Code is lenient, we need to be little stringent. However, in case of absolute absence of additional material, we will have to go to the nearest material in the same P number and use it. Type or grade, whether it is grade 60, grade 70, not only 60, 70, but is there specific impact, or whether it is we want it to be hot rolled only or cold roll only, or any other specifications in the type we can specify and use it. Material condition, annealed, heat treated, normalized, stress relief. So those conditions will also come into the picture in addition to above. If there are any grain size requirements, those can also be brought in, especially when there are impact. We may choose finer grain materials, and even though it is going to fall in the same P number, a higher grain material may impact, even though our consumables, welding parameters may be good. but the parent metal itself is not going to have sufficient impact because of the coarse grain. So these material conditions are also very essential to write down in WPS as well as in PQR, so that we don't miss out on the important aspects when we are going to do the welding and qualify our procedure. The thickness of the plate which we are using it, if it is a pipe, it is a diameter, or if it is both pipe and a plate, or pipe to pipe, diameter will come, thickness will come into it. Method of pre-cleaning, once again as prescribed in the WPS, will be using either emery paper, hand wire brush, power wire brush. Post brushing, are we going to clean with acetone, acid? Sometimes etching is required in certain alloys, like titanium gets etched before it is welded. So the etch preparation and how the pre-cleaning, post-cleaning is required to be done in that. Let's move to the right side. This is the post-weld heat treatment. Once again, as we saw, how are we going to do it? The way we are doing, every parameter needs to be recorded in this. And if we can record along with the size, the weight of the overall PQR plate, so the quench effectiveness, we can assess the tank size, the quantity of the oil, quantity of the water, if we have used the mist spray, how many nozzles were used. Finally, the whole idea is that from PQR to actual job, we should not have variation to the extent possible, as PQR is the one on which the designers are going to use and base their calculations. So on the job, we should not have any variations. So that's the idea of recording as many details as possible in this weld heat treatment. Filler wire, once again, F number, A number, as we discussed in WPS, very essential to write A number on the PQR. Let's ask the lab which is testing our PQR to do some chemical analysis in the center of the weld, in the 1/3 from the center and near the heat affected zone where there is going to be a dilution, and confirm that A number, the chemistry is not varying much, and from parent metal to the main center line of the weld, there is not a very large variation in the chemical composition. And then write in our PQR what is the A number we actually got. F number is what is certified by the consumer manufacturer, so it's very easy. He also gives SFA number to which standard, SFA 5.1 or 5.17, all that numbers will come on the test certificate of the consumables, which are required to be written down, including the heat number or the lot number of the electrodes, so that we don't miss out anything on it. The size of the filler wires which are used, layer by layer, pass by pass, this is required to be noted. Brand name, in case we want to specifically qualify a particular brand or a lot, then it is essential to record it here. And deposited thickness, layer by layer, if pass by pass, if we can make a chart and write it down there, and the profile what we achieved, it will be a good input for us to do any subsequent analysis. Weld metal thickness range in the groove, in the fillet, what is that we have given, the reinforcement, the penetration side, and whether we filled up the complete groove, and if there are multiple processes, to what thickness each of this process has been deployed and deposited thickness is achieved in each of it. Then comes on the right side the electrical characteristics, that is the current, AC, DC, pulsing, non-pulsing, straight, square wave, synergic, all those parameters, the polarity to the electrode, what has been given, what's the voltage. Good to record the OCV, the open circuit voltage, which is before striking the arc, and then after striking the arc, what is the voltage we got. Tungsten electrode type, tungsten electrode diameter, mode of metal transfer, as we discussed in WPS, spray, globular or short circuiting, and Now modern machines give a flexibility between wire speed and the current, so good to record the wire speed. What we need to do is, in case we don't have a meter, we need to use the same setting and mark 1 meter length or 2 meter length, or in 1 meter how many meters wire has come out. Or we can keep, while PQR, the wire feeder, the lead of the wire feeder open, and mark on the wire spool some marking and count number of revolutions in a minute, and from the revolutions we can find out the circumference, and we can easily do it, so we don't waste wire or we don't expose wire. And while welding itself, this test is possible to do it. Preheat, once again, how we do the preheat, it's not only the temperature which is required to be maintained, but you have to make a small sketch and write down how you heated it from other side or 3 inches away from the material. How did you check it, whether you checked it with laser, whether you checked it with temperature stick, whether you checked it with the other means of temperature measurements, and how did you took a decision to start the welding. Similarly, the interpass temperatures also, what method was used, and where did you really checked it on the PQR plate. So now everybody has a mobile, taking a photograph or having a camera and taking a photograph is not difficult. So make PQR also as richer as possible with more and more details like WPS, so that we have a complete history, complete data. If you can take a video and upload it on your system, on your server for a particular PQR, I think that will be another great thing, and we can move one step nearer to AI in welding if we have all this data properly recorded. If the preheat has been maintained, how we have maintained it, whether we have used electrical burners or we have used gas burners or we have used infrared burners, and what was the position of that, and try to think on the actual job, how are we going to do it. All this is not only adequate to satisfy on a PQR plate, but whatever we have done on PQR plate, to the same accuracy can we bring it onto the actual job. That's where the welding engineer has to really put his lot of energy, efficiency, visualize the difficulties on the job, what are likely to come, and try to simulate them in the PQR. Then comes whether we have used single bead, weaving of the weld, and like in WPS we said, quantify that, whether you have viewed it, measure it actually and record it. This pass we have viewed it to 5.5 millimeters, the next one got up to 6.5 millimeter, and then the stringer bed width was 3 millimeters or 4 millimeters. What was the depth of the stringer bed, that means the amount material deposited, 2 millimeters, 3 millimeters, and like that we have to make as richer as possible. WPS and PQR have been repeating again and again. We take it very lightly, we don't detail it out, we make it very flexible. If these details you are scared of being shared with somebody else, then you can have the basic data here, but don't miss out to put attachments which will be your own kind of IP, and that IP will be protected only by your organization, because that data you will just manage to write down whatever is needed in the WPS PQR for getting it approved. But beyond that, all the techniques which we have used and for which this entire WPS PQR videos I am doing it in so detail is to have a record. The welding engineers, like welding inspectors, they will come, see the route run by a welder, stamp the plate and go away. For them it is okay, they are not the ones who are going to execute it. Their idea is to see to it that we have a proper record and the strength, especially parameters, are achieved. Rest everything is the responsibility of a fabricator, and that is where, as a fabricator and as a good engineering practices, or to really give a quality product and use PQR not only to satisfy customer requirements but to really make our product easier, faster, cheaper, and don't land up into any quality issues as we are proceeding. Multi-pass welding, single pass welding, as many details it is given here, you have to write it down. Let's continue and go on to the second page. Unlike WPS where we separated out because the discussions were more, I think because of the WPS discussions, PQR will be able to finish it faster, both the sheets. Next is the specimens. Here we have the TR1, TR2, TH1, TH2. You can give whatever nomenclature you have for the transfer tensile, for the whatever room temperature, high temperature, bend test, root bend, phase bend, whatever is given in section 8, section 9 is required to be followed and noted down here. So once again, you write down the plate or write a sketch, draw a sketch of a plate from where what samples have been taken, and depending upon your UTM the specifications, you will be taking more number of specimens in case your tonnage is less. So those details are also required to be done. When it comes to the impact, you have to be very careful to ensure that you do a proper etching. If you are going to have an impact in the parent metal, if you are going to have an impact in HZ, if you are going to have an impact in the weld metal. So each the specimens, mark it correctly, and then only make a groove or a notch on the impact specimen. And as far as possible, try to avoid the subsized specimens. When there is a limitation of a thickness, non-availability of the higher materials, please go for the subsized specimens. But don't forget to validate with the codes, because the subsized specimens may have a different criteria for acceptance as far as these physical properties are concerned, depending upon the nature of the material and the way you have taken the specimens. So, and next important point, which is many times missed out, is to keep these specimens along with the PQR. You have to have some proper storage identified for it, and write down the fracture location. Insist on the lab to give you a fracture location and the type of fracture. Fracture location is whether the not only we want it is within the gauge length, but within the gauge length, was it in the weld, was it outside the weld, was it in HZ, the fracture was after the making. Of course, the elongation properties will tell us, the reduction in area will tell us whether making has happened or no. But good to record, take a photograph of the fractured specimens and see the type of fracture, whether it is a brittle fracture or ductile fracture, and correlate with the rest of the observations or the physical properties what we are getting. Similarly, hardness also, one has to be very careful. If you are taking hardness in heat affected zone, only after proper etching. You cannot assume that heat affected zone is what I roughly see a weld edge, I will take about 0.2, 0.3 millimeters away. It is not possible. And as far as the yield is concerned, yield load is very difficult to calculate on a welded specimen sometimes, especially when you have very low elongations up to 7 to 8, 10%. Above 10% you will see a yield point very clearly, but below that very difficult to do it. So the technology helps. You have better machines now where you get stress strain diagrams very nicely done up by the machine itself, and a 0.2% offset is also through the program. However, just because it has been done by an automatic machine or by a software, don't assume it. See to it yourself, counter check that everything is okay, and then only sign or certify on those materials. Hardness we discussed after doing HZ, weld, parent metal, both sides. Even if both sides materials are same thickness, good to check hardness on both sides. And then other tests like micro, macro, and then flattening of tubes if it is there, corrosion test if there are specified, impact test if there are specified, visual test. This is very important to write down. How did you found the visual appearance of this weld. Was it shiny? Was it had a good contour? How were the ripples? Whether they were uniformly spaced? Did you find any undercuts? Did you find any surface defects like porosity, crater, or any other defect what you are finding it in the PQR is good to record and take a photo and have it with us. Then the reinforcement weld geometry, penetration side, what was the depth after flushing, after grinding on the reinforcement side, did you keep anything 0.2, 0.3 millimeter extra, and then was it machined later on when the specimen was made? Was the specimen completely flat, or the code allows you to keep some of the codes reinforcement if that reinforcement was kept on the weld, and then you tested it? So what was the cross section of the thickness you took it for the calculation of area, because your strengths are going to be force divided by area. So, and then you have to do the RT, UT, LPT, whatever is going to be conducted on the actual job, or maybe in PQR some additional tests are specified which are not possible to do it, but that gives a confidence on the job. The welder who welded it, in which position he welded it, welder details like his stamp and welder number, who conducted it, where was this conducted, the location in the shop floor or the training center, and what machine was used, what electrode, how electrodes or the consumables were stored, how they were baked, submerged or fluxes if you are going to use it, how much quantity of flux did you draw from the oven, was it recirculated, or did you use every time for every run a fresh flux. So all this, I'm trying to give you all possible variations which can happen on the shop floor are required to be recorded in the WPS and PQR, and certify them for everything what you have done. So later on when you are going to have any defect analysis or any corrections which are required, or we want to improve our performance in the WPS by having another PQR, so what changes we should really bring in this PQR, the way we conduct it, and if there are going to be any additional mock-ups, as I said, don't share with somebody who is likely to have infringement on our IP, but at least internally we should attach along with this PQR or WPS or internal mock-ups and the results, the various trials what we conducted, and how did we develop this entire technology or the process to meet all the specifications, dimensional requirements. We are going to measure what is the bend the PQR plate had. If PQR plate bends, then you will not be able to take your specimens, so then you will have to use the corrections, whether that correction was done by welding, by heat, by mechanical force, and replacing it under the press. So how have you corrected it, and what was the angle you got, the bend angle? Was there a distortion in the longitudinal side also, or was it only a transverse? And if it is a pipe, whether there was a shrinkage in diameter, whether the overall length also shrink because the shrinkage in diameter, distortion. So length of the pipe before setup, after setup, and after welding, diameter of the pipe before setup, after setup, and after welding are required to be recorded and registered into our data log, and then transferred into a digitized thing. You can scan and upload your images of the data what you have logged in, or you can key in on Word or Excel sheet, or you may have a software on which you will be able to do it. Similarly, upload all the photographs what you have taken when you are going to do your heat treatment, how your plate has been loaded, horizontal, vertical, and where was the position of this PQR plate in the furnace. So do as many details as possible so that we don't miss out, and in case of a non-conformance, analysis will become very easy. So I hope like WPS, the PQR discussions also were good, you liked it, and you will be able to improve on your PQR. As I said again, if you don't want to share your IP with others, just do it the way you are doing your WPS PQR as you are doing it today. But all other parameters or important points what has been discussed in the last two WPS videos and this PQR video, try to make your supplementary sheets and keep it along with your internal WPS, your internal PQR, or on your digitized system, and give proper explanation for every activity what you have done and you have recorded, and sign off for each one of them with time and date, as well as the person who is recording it and the welder or welding engineers who are conducting it. Similarly, the NDT, the lab test persons, everybody has to give his assurance that it has been conducted in the way it has been prescribed, and we will be able to really do it. Then only we will be satisfying. The code has so many pages, every page is explaining. If you go to these various clauses which are explained here, QW483, if you go to other, you have QW408. So 408 itself is more than 25 pages. Now, why they have given so many details in that QW408 is to us to understand, even though we are recording few parameters here, the significance or the impact of each of these parameters on the way welding is going to be behaving in the job. So thank you so much, and we will have a similar video on WPQ now. Thank you.